Dual nature of particles and the future space technology. In this video, we will discuss two types of motion of particles and how we can use it in our future space travels. What we are discussing is how particles use space-time when they exhibit wave behavior and when they exhibit the particle behavior. You may find it surprising that particles travel in two different modes, but we can prove that it is possible. This is a fact that we have overlooked in the double-slit experiment. So why do particles exhibit dual nature? We didn't ask this question until now. So now we are going to discuss how particles can exhibit both particle and wave properties at the same time. Earlier we thought that light had only a particle nature, but we learned that light exhibits particle properties as well as the wave properties. We have proved it through the double-slit experiment. But the problem that bothers me is why light exhibits these two qualities. This will not happen without any fundamental reason. The double-slit experiment shows us the two kinds of motion of light or particles inside the space-time. To learn more about these different types of motion, let us examine the structure of our solar system in detail. Each particle interacts a certain amount of space-time with it, according to the energy stored in it. The solar system can influence space-time in proportion to its total mass. We know that the Sun is at the center of the solar system. Planets and other objects in the solar system orbit the Sun. So it can be said that all these are within the space-time of Sun. We can take the Sun and the Earth as the examples to understand in more detail. The Sun has a space-time proportional to its mass. According to the general theory of relativity, the Earth is located within the curved space-time of the Sun. Naturally, the Earth can also create a curved space-time proportional to its mass. Although the Earth is located within the Sun's space-time, the Earth is creating its own space-time over there. Now we can see two different space-times within a system. So the Moon can create another space-time within the Earth's space-time. Although within the space-time of the Sun, the Earth's space-time is independent. The Earth's space-time has all the characteristics of the Sun's space-time. That is why the Moon can create its own space-time within the Earth's space-time. Now we met three different space-times within a single system. Now let us see how they move. As the Earth orbits the Sun, the space-time with it also accompanies it. Otherwise, the Moon, which is located within Earth's space-time, could not remain there. Here we can see that the space-time also moving according to the direction of the motion of the mass. The Moon's movement with the Earth is the best evidence for this type of motion. So if the Earth disappears from the solar system, the Moon will also disappear with the Earth. The solar system will also lose the proportional space-time. Now let us look at another type of motion. Suppose we are throwing a stone into a pool of water. The stone will sink into the water soon by making waves on the surface of the water. Here we cannot see a motion like the one we see in the solar system. When the stone is submerged in the water, it leaves its own space-time on the surface of the water. That space-time is added to the Earth's space-time. Whenever the stone is taken out of the water, the space-time will be added to it again. If we examine here in detail, we can see that there is only time with that stone. Space is added to the Earth's space-time. It is happening like this because the characteristics of water and the space-time are different. So let us see what happens when an object moves from one space-time to another with the same properties. For that, we can observe the motion of a photon. Suppose a photon enters the Earth's space-time from within the Sun's space-time. That photon is capable of two modes of motion. It can travel through the Earth's space-time while keeping its space-time with it, like the motion of the Moon within the space-time of Earth. Similarly, a photon can move freely by attaching its space to the Earth's space-time. Later, when it goes beyond the Earth's space-time, it can regain its own space-time. We can see these two types of movements in the double-slit experiment also. While the detector is active, it may add its space-time to the Earth's space-time. When the particle adds its space-time to the Earth's space-time and freely moves in it, that particle shows its particle behavior. This time, the particle interacts directly with the Earth's space-time. When a particle holds its space-time with it while traveling in the Earth's space-time, that particle shows wave behavior. This time, space-time of the particle interacts with the Earth's space-time. So the particle can easily switch its space-time. If we can switch the spaceship space-time to the hosting space-time and freely float on it, we can achieve an incredible velocity. Also, in all of our movements, we are carrying space-time with us. Even our spaceships are following this type of motion. So we need to find a way to add the object space-time to the parenting space-time. Then the object can freely float in the space-time. If we can use this possibility in our space travel technology, we will have a revolutionary breakthrough. If we can understand how energy and space interact, that is the key to the mysteries of the universe. All these things are well described in our book, Key to the Secrets of the Universe. Even you can find more details in our website. Also, you can watch our other videos for more information. All the links for the book and our website is in the description box. Thank you for watching our video.